All right, this is problem 4.86. Your values will be a little different than mine, I think, because it's randomized. But it says a crow's flying horizontally with a constant speed of 2.7 meters per second. So I've got my crow, which I'm just going to make this circle, flying forward at 2.7 meters per second. Excuse me, I didn't have my stylus with me at home today, so hopefully my writing can be okay with my fingertips. That clam lands on a rocky beach 2.5 seconds later. The questions ask, what is the horizontal and the vertical components of the velocity? The horizontal is easy because the whole time this is falling, it's falling with 2.7 meters. There's nothing to slow it down because we ignore air resistance, right? So the whole time this is falling down, it's always falling at 2.7 meters per second. So I don't have to do any work. The answer is just 2.7. Which just leaves me the vertical part. Now this clam, it starts off in the bird's mouth and it starts falling. Which means, at least in respect to the y, I don't have any initial velocity. And it starts falling under the influence of gravity, it starts to speed up, right? Which means my v final is what I'm looking for. I happen to know the acceleration on Earth is negative 9.8 meters per second squared, and that the time this took to fall was 2.5 seconds. Now remember, we've already found the x, and the y is just a 1D kinematic problem. So let's take a look at that problem. I have that information that I was given, and it all happens to fit the formula Vf final equals V initial with respect to y plus the acceleration with respect to y times time. Now, my starting velocity is 0, so this term goes away. And my final velocity, at least in the y direction, is just equal to the acceleration of gravity times the time, 2.5 seconds. And I can do that math. It's going to come out to just under 25 meters per second. I think it comes out to 24.5. Don't quote me on that. I don't have a calculator next to me this second. And that's it. My y direction down, this is the speed. So that's going to be where I end out. This is how fast it's going down vertically. And my horizontal we've already taken care of. And I don't have to do anything else. My answers are done. So that's the first one.